This is Unit 1, Lesson 3, Vocabulary. There's lots of vocabs: angle, ray, opposite rays, acute, obtuse, right, straight angle, angle bisector, and angle addition postulate. Angle. An angle is formed by two rays with the same endpoint. The rays are the sides of the angle, and the common point is the vertex. The vertex is where they meet. So there's your definition, here's your drawing, and your notation. Angles can be named by just the vertex or by 3 points from the side down to the vertex out the other side or the other way around. Notice the vertex, that A, is at the center of all of them. You could not call this angle ACB because it's not a matter of alphabetical order, but it's a matter of as you flow. AC, there's nothing to get you up to B. So B, AC, C, AB, but your vertex is going to have to be in the center. Ray. A ray is part of a line that consists of one endpoint, and all of the points on the line on one side of the endpoint. Essentially, it's a line where, think about a line segment where you've cut the arrows off of both ends. In a ray, you've cut the arrows off of only one end. So it has a definitive starting point, and it goes towards infinity in only one direction. We read this as ray AB. What's important about naming a ray? Sorry about that. What's important about naming a ray is that when you draw your arrow that you're using, for instance, ray AB, this line does not change. So even if it's going the other way, A to B, even though it's pointing the opposite direction, the symbol for ray only looks like this. And that's where these letters come in handy. This letter represents the endpoint. This represents towards infinity. So looking at this ray here, A is the endpoint and is going towards infinity, towards B. A is the endpoint, the first letter, B is the second, out towards infinity. If you wanted to switch it, even here, A is the endpoint, B goes towards infinity. If you really wanted B to be the endpoint, B would come first, A would be out towards infinity. This one would be called BA with that ray over top. Rays are the hardest to name because with lines, with segments, you can reverse them. Rays are not reversible. That first one here is the endpoint. B tells you, or that second letter tells you where the arrow is going. Opposite rays. Opposite rays are two rays that share the same endpoint and form a line. The idea of forming a line is important because angles share the same endpoint as well, but they're not opposite rays. Opposite rays lie in the same line. So, and my picture got cut off. This particular ray here in purple starts at C and heads out towards A, heads out towards B. The other one, which I'm highlighting in red, starts at C and heads out towards A. So I'm going to call it C, A. That arrow does not change. Notice the direction is always the same. That's just a symbol. That's what it looks like. It's not there to tell you left or right. It's there to tell you what it is. Then the other ray starts at C and goes towards B. It may appear that both of the arrows are going the same way, and it's only because the symbol is. The red ray starts at C and goes towards A. Look at the diagram. It's going to the left. The purple ray starts at C and heads out towards B. Look at the diagram. It's going to the right. Rays, by far, are the hardest. Classifying angles. I don't think there's any new information here. Any type of angle marked with a 90 degrees or marked with this little right angle is 90 degrees. You cannot assume that something is 90 degrees. That has to be told to you, so that marking has to be there in order for you to say, hey, that's a right angle. For instance, this one. I'm reasonably good at drawing diagrams, but unless I specify what I want this to be, you can't make the assumption that it's absolutely 90 degrees. Letter B. Is it less than 90 degrees? Then we will call it an acute angle. If it's larger than 90 degrees, we'll call it an obtuse angle. Notice it has to be less than 180, so between 90 and 180, and this one should probably be bigger than 0, but less than 90 as well. If it is absolutely 180, it's referred to as a straight angle. So our 4 different kinds: right angle, acute angle, obtuse angle, and straight angle. Notice that there are not any or equal to. If it were equal to 180, it'd be a straight angle. If it were equal to 90, it'd be a right angle. When we talk about notating, there's no special notation. So if I were to call this angle ABC, your notation would just be to say that angle ABC is a right angle. There's no special symbol. This symbol right here is a shortcut for any angle. I could do the same thing here. Let's call it different letters. D, E, F. And I could say angle DEF is an acute angle. GHI, angle GHI is an obtuse angle, and I could call this JKL, angle JK, oopsies, darn it, give me my pen back, there, angle JKL is a straight angle. So no special notation other than the little angle symbol. Angle bisector. Segment bisector and angle bisector are very similar. The idea is that the bisector is the knife, that's what's doing the cutting. The angle is what's being bisected. So it's a bisector is a ray that divides an angle into 2 equal or congruent parts. So here's your blue angle, and here's your bisector that's doing the cutting. Notice these little curves. It's telling you that they're the same measurement, that they are congruent. Please note that this is not a midpoint. That's a vertex. When we talk about midpoint, we're talking about the middle point of a segment. This is the vertex of an angle. But these 2 angles are now the same. So how can we do it? Or how do we notate it? We can call it like it is. Let me get all my markings out of the way here. That black bisector starts at F and goes towards B. Ray FB bisects angle PFQ. Just describe what's happening. I could say that angle PFB is equal, I'm going to say the measure, and we'll talk about that in class, the measure of angle QFB is equal to the measure of the other. Or I can say that those 2 things are congruent, that this physical angle is equal to this physical angle. So no special notation for the word bisect. You have to tell it like it is, or specify what 2 pieces are congruent because it was bisected. Bisected meaning cut in half. Think about that prefix bi. Angle addition postulate. Angle addition postulate is very similar to the segment addition postulate, but for angles. What we're doing here is we're saying that the part of an angle plus another part of the angle is equal to the whole angle. That if this were 30 degrees and this were 30 degrees, then what's the measure of the entire thing? Well, it's 60. This plus that equals the whole. So it says if 2 angles are adjacent, and I have to work with the word adjacent in the next set of vocab. If 2 angles are adjacent, which it just means side by side, then a part plus a part is a whole. All of this says that if these 2 angles, and they're ADB, BDC, are adjacent, then the measure of ADB plus the measure of BDC BDC is equal to the whole. This is a part, this is a part, and this is a whole. Add up the pieces. Whoops, not who, whole. Referring to notation, well, it's kind of, the definition and the notation are kind of the same here, but there's your drawing to go with them. And that concludes this video. Let me know what questions you have, jot them in the margins of your papers. Again, the purpose is for you to get a gist of what's going on so that we can discuss it and go deeper tomorrow. Thank you.